Hello, today we're going to be reviewing factoring, which is chapter 7, part 2. So the first thing we did with factoring was finding a prime factorization of a number. So when it says find the prime factorization, that means we want to break down our number until it's only prime numbers. So if we take 144 and keep on dividing out numbers, we'll eventually get to all prime numbers. So if we take out a 2, we would be left with 72. If we took a 2 out of 72, we would be left with 36. If we take 36, we could divide it by 6 and 6, or 9 and 4, or 2 and 18. However you want to break it up is totally fine. Then you keep on breaking all of your numbers down until it's only prime numbers. So 144, when you break it down, there's a 2, a 2, a 2, and a fourth 2, and then a 3 and a 3. With our variables, we're just going to list A once, but we will list B out 3 times because B to the third power means B times B times B. This is your prime factorization. Now, your prime factorization can help you identify the greatest common factor, aka your GCF. Or if you look at your numbers and you already know what they have in common, that's great, okay? So looking at these numbers, 16, 24, and 32, we're going to look at the number side of it first. You can divide them all by 2. You can divide them all by 4. But you also can divide them all by 8, which is why our GCF would start off with an 8. And you can always test it. If you divide these by 8, you should get nice numbers back though, because they all have 8 in common. For your x's, you ask yourself, what do those have in common? And one has 3, one has 2, one has 1. So overall, they all have at least one x. This would be our GCF. So now what we want to do is we want to take that GCF and factor the GCF out. The first thing is to go ahead and identify what is your GCF for this problem. So 5, 10, and 35 all have a 5 in common. And x to the fourth, x to the third, and x squared all have x squared in common. So we're going to take that GCF of 5x squared out, and in order to figure out what is left behind there, what we can do is we can divide everything by 5x squared. So 5x to the fourth divided by 5x squared becomes x squared. Then we have a minus. 10 divided by 5 is 2. And we have one extra x left over when we divide out 2 of them. Plus 35 divided by 5 is 7, and our x's cancel each other out. This is what our answer looks like when it asks us to factor out your GCF. Now we're going to go ahead and factor our quadratics. So all of these down below here are going to be using different methods of factoring. So for number 20 here, when a equals 1, when there's nothing in front of your x squared, there's an implied 1 there. What you're going to do is we're going to look for what multiplies to get your c value, but adds to get your b value. So deal with your multiply numbers. You can do 1 and 9 or 3 and 3. And the one that actually works to get the add number is if you have the 3 and 3, but they were both negative. If you have a 1 out in front, this is a shortcut method. So what we can do is we can go ahead and put down our parentheses, and we can write x and x. And then whatever numbers you got, you're going to plug into your parentheses, and you're going to get x minus 3 and x minus 3. Now you can always go back and check your answer using the distributive property. So x squared minus 3x plus 9. When you look at this, this is exactly what you started with, which is why this is correct, because you have unmultiplied it successfully. Now number 21 here is saying, look at this, this is the exact same equation, but now instead of just factoring it, we want to solve it because it says equals 0. So I'm actually just going to steal my same factoring from that one because it is the same problem. So when you're solving, you want to factor first and set each factor equal to 0. and then solve each equation. So this first factor is x minus 3. This other factor is also x minus 3. And when we solve each of these equations, we end up getting the same thing, x equals 3. So our solution for this one would be x equals 3. Sometimes you might have more than one answer, and that's okay. You can have 1, 2, 3 answers. It all depends on how many factors you have. Now let's take a look at a factoring method when a isn't 1. When you have a number out in front here, this is called split middle term. So you're going to take this number out in front and you are going to multiply it by your C value. So you're going to multiply A times C. When we do 3 times 12 for this one, we get 36. The add portion is still going to be your B value. So in this case, it's 20. So A times C is your multiply number. Your B value is your add number. And so you list out your options. So what multiplies to get 36? Well, we can try 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Of these options, the add portion works with 2 and 18. So our numbers are going to be 2 and 18. So we cannot just write our answers as x plus 2 and x plus 18. Instead, for this one, we have to rewrite our first term as 3x squared. You rewrite your last term, whatever your C value is, and you split up your middle term into the two numbers you just got. So we got a 2 and an 18, and so we're going to put an x with both of those. Then we're going to go ahead and chop this in half, and you're going to ask yourself, what do the first two terms have in common? And so for those two terms, our GCF is x. So what we're going to do is we're going to divide out an x for each of those, and we would be left with 3x plus 2. Notice we put our GCF out in front, and we put whatever is left behind in parentheses after that. For the next two, you ask yourself, well, what does 18 and 12 have in common? And so those have a 6 in common. So we put our GCF out in front, and we divide each of our terms here by 6 to get 3x plus 2. Now with split middle term, these two parentheses have to be the same. So 3x plus 2 is going to be one of our factors because we are going to take that out. And our other factor then is going to be x plus 6. This would be our answer for number 22. And once again, you can distribute this to see that it works. Now, 23, once again, notice it's the exact same equation as the one before. So what I'm going to do is I'm going to go ahead and take my factored form, because since it's the same equation, it's going to have to factor the same exact way. Now that you have it factored, the new part is the equals 0 part. So we're going to go ahead and take each factor and set it equal to 0. And then you're going to solve each equation. So your solutions for this one would be x equals negative 2/3 and x equals negative 6. You only have to solve these ones again when there's an equal sign. So we have done our shortcut method, we've done split middle term. There are a couple more methods here of factoring. So the first one being the difference of two squares. If you have two perfect squares with a minus sign in between, you can basically square root each term, and in each factor, the first term is going to be the square root of the first term. The second term in each factor is going to be the square root of the second term, and you're going to have 1 plus and 1 minus. This is the difference of two squares. So for instance, this first one, we can square root 100y squared. The square root of this would be a 10 and a y. We also can square root 81x squared. The square root of this would be a 9 and an x. And then in between these, we would have one positive and one negative. This is the factored form of our original problem. Now, number 25 relies on a slightly different method of factoring, but the good news is we've actually already practiced this skill. We are going to do grouping for this one, but in order to do grouping, it's the same process as split middle term. It's just you don't have to break it up because it's already broken up. So here we have 4 terms. We're going to split this in half, and we're going to look at what the first 2 terms have in common. These 2 terms have an m squared in common. So if I divide out an m squared, let's write an m squared here instead. We write our GCF out in front, and we write what is left behind when we divide out our GCF. The next 2 terms have a 9 in common, and because my leading term here is negative, I'm going to factor out a negative 9. So I'm going to divide each of those by negative 9. I would be left with 4m plus 9. So one of my factors here is going to be the 4m plus 9. The other factor here is going to be the m squared minus 9. Now, we might be circling our answers right now, but looking at this, we have to be careful because we have to ask ourselves, does anything else factor further? And 4m plus 9 does not keep going, but m squared minus 9 does keep going. So m squared minus 9, we're going to use our factoring method that we just did on the last one, so the difference of 2 squares. So the square root of m squared is m. The square root of 9 is 3, and we have 1 with a plus, 1 with a minus. And then we need to make sure we bring down anything from our problem that we didn't use with our new method of factoring. So the final answer here would be all 3 of those factors put together. Thank you very much for listening. I hope this helped. If you have any questions, please let me know.